The final item that we're going to look at in this section is being able to reverse the order of integration to evaluate double integrals that are non-evaluable as either a type 1 or a type 2 integral initially. So, for instance, let's take a look at this first double integral that we have. 0 to 1, 3y to 3, e to the x squared dx dy. I want you to notice that initially this is a type 2 double integral. Notice that we are going from left to right because dx is the first in the order of integration. So what we'd like to do is we'd like to be able to flip it around and make it into a type 1. And I want you to notice why we can't evaluate it. We have this e to the x squared. We know that e to the x squared does not have a basic antiderivative. So here's the process that we're going to utilize. We know that the lower bound is x equals 3y. Or, in other words, that's going to be x over 3 is equal to y. We also know that the other bound is x equals 3. So, what we're going to do is we're going to graph this region and then change it from a type 2 to a type 1 region. X over 3. So let's just go ahead and graph this. Okay. Now, x over 3 obviously contains the point 0, 0, which is our origin. And if x were 3, then y would be 1. Right, so we have this relationship. Okay, so this is the curve x over 3 is equal to y. The other relationship that we have is we have the line x equals 3, which is going to be a vertical line passing directly through 3. So this is our line x equals 3. What we would like to do is we would like to make this into a type 2 region. So a type 1 region, excuse me, meaning that we're going to go up and down as opposed to left and right. So I want you to notice the new boundaries. I want you to notice that we're going to start with y equals 0, and then the upper bound is going to be x over 3 is equal to y. Okay, so those are our bounds. And then the x bound is clear. We start at 0, and then we go to the point 3. Alright. We're going to reverse the order of integration, turn this into a type 1 integral. Alright, so to reverse the order of integration again, first thing you want to do, you want to graph. Then what you'd like to do is to take a look at the graph and then go from there to be able to reverse the order. We're going to rewrite the integral. So our new double integral, remember, the first integral should always be the variables. 0 to x over 3, 0 to 3. We still have e to the x squared. But instead of dx dy, notice that we took care of y first. So now we have dy dx. Clearly, what we can do at this point is we can go through and just evaluate the double integral. So we know that because there is no y in the original integrand, we could just rewrite this as 0 to 3 y e to the x squared, and y is going to range from 0 to x over 3. We still have dx. We're going to substitute x over 3 minus 0 in for y. So now we get the integral from 0 to 3. Instead of y, we're going to have x over 3 minus 0, e to the x squared dx. Or we could just rewrite this by factoring out the 1/3. We have 1/3 integral 0 to 3 x e to the x squared dx. Now this is evaluable. This is a clear u substitution problem where u is going to be equal to the composite function x squared. So we're going to say u is equal to x squared. Du is 2x dx, which is good, but we just don't want 2x dx, we want x dx. So what we're going to do is we're going to divide both sides by 2 to get that x dx. So now wherever we see x dx, we're going to replace that with du over 2. Wherever we see x squared, we're going to replace that with u. So our new integral, solely in terms of u, not in terms of x, is going to be 1/3 integral not from 0 to 3, from a to b. Instead of x dx, du over 2. Instead of e to the x squared, e to the u. Another way to rewrite this integral would be 1/6. We have our 2 and our 1/3. Integral a to b, e to the u du. We like e to the u du. It's about as basic as we can get. So what we're going to do is we're just going to evaluate. This just becomes 1/6 e to the u from a to b. We're going to back substitute. So if we do that, just give ourselves a little more room here. We're going to end up with 1/6 e to the x squared from 0 to 3. We're going to substitute 3. We have to substitute 0 this time because it's not a polynomial. So we're going to get 1/6 e to the 3 squared minus 1/6 e to the 0 squared. Or we could rewrite this as 1/6 e to the 9th minus 1. Or we could just move that 1/6 to the numerator, and we could end up with 1/6, e to the 9th minus 1 over 6. Make that look a little bit better. I'll just erase the whole thing. So we can just write it as e to the 9th minus 1 over 6. All right. So suggestion would be at this point, work through the next double integral, by utilizing the reverse of the order of integration. All right. Again, it looks like it's a type 2. Flip it around to a type 1. Maybe take about 10 or 15 minutes, see if you can evaluate it, and then watch the final video from section 21.